Hey everybody, this is Dark Guardsman and we're back. So we're going to go ahead and actually implement the math we've been creating with the visualization software into ICBM itself. And I figured rather than just doing this and talk about it, we're going to walk along and I'll show you what the old stuff looked like, how we're going to put the new stuff in there, and some other minor changes that we're going to make in the process in order to kind of clean up what we had. Right now we're going to do this with the 1710 code, but the fact is like the 112 code looks almost exactly the same for the missile. So we're going to be modifying any missile. Any missile has two functions for handling the current mathematics. It has a recalculate path, which does some basic mathematics to figure out kind of the data set, so it figures out 4 variables and how they're going to be used. And then with those 4 variables, it then comes down here, and after it's done its lock height system, it will then set the actual motion of the missile, and then down here it'll decrease the motion of the missile. So the acceleration value we have is not actually acceleration. It's actually a better way to even think about this. It would be drag, actually. So this is what we're going to end up actually probably calling it. And let's think of a couple of names here. So we want to make sure that when we actually go through and rename these to make them more understandable, is we're going to want to name them with something that is unique to what it's being used for and easy to understand, so that way you don't actually need Java docs, although we will implement Java docs to go with this. So right now it's just called acceleration, but what I think we're going to do is call this missile path drag is what we're going to call this. And if it doesn't actually cancel out, sometimes when you rename things when you're in this, it will actually try to, it's supposed to actually pop up a message. So we're going to go ahead and do this again because it didn't pop up what it was supposed to be. So missile path drag. There it goes. This is what it's actually supposed to pop up as refactor view. For some reason, it didn't pop it up. You want to exclude comments or it's going to rename your comments. I don't know why it defaults with that. So we'll go ahead and rename that, and we can just ignore this current one, which we hit X to get rid of it. So it'll rename it the missile path drag, which is very useful. We can come up to the top here, and we can actually put a Java doc to this. So this is... Oh, it just broke. Oh no, I thought for a second you saw the red down there was breaking all the imports. So the amount of pull towards the ground the missile will have while arcing towards target. So this is basic what this variable actually does. So it's good that we actually name that. Missile flight time is still pretty good, so that's actually the amount of time it is. So this will be, and we'll go ahead and rename this as well. So we'll put a Java doc above here so we know exactly what it is. Amount of time it will take to reach target. It's always good to have Java docs on top of actually having it. So this will be, we'll go ahead and rename this. So this will be missile path time is what we're going to call this. It's the amount of time it should take the path. And this will be flat distance. So flat distance is actually literally exactly what it sounds like. It's the flat distance between the target from start to finish, ignoring Y. So distance to target, ignoring Y change. So we'll change this as well. Missile path distance. And we're actually call this flat distance still, so it's easy to understand. So that way we have that, and we're going to go ahead and break these apart. So we have protection time, which is something we're not going to be using. What else do we got in here? So we've got some mega junk in here we might as well clean out. Some stuff that's still named in Chinese. We're going to find Chinese throughout this mod until like the end of time, basically, is what this is going to look like. So we got our delta values here. I actually am going to change this to be a vector just to make it easier to work with. So this would be pause 3D. Or actually, I think it's just called pause, and this will be missile path delta is what we're going to call this. Hopefully I won't cause any problems. And this will be distance to target is basically what this will be. And we'll put that down there so it's with everything else. And the cool thing about changing it to that is when we can actually come down here, and instead of doing what we got here, we can go this dot, we call that missile path distance. What do we end up actually calling that? Yeah, path delta is what we actually called it. So this is a change in direction. It's the reason why you call the delta for it. So this would be the target vector, subtract the source of the projectile. And that way it'll clean that up, and that'll make that code easier to work with. There's a couple other spots that still use it, so we'll have to make sure we actually access it correctly. So this would be missile path delta, and this would be the X. This would be missile path delta Z. And let's make sure we initialize this as well to something, so that way there's not a chance in the world that this should null point, which would make our lives a little easier. Looks like it's used in another spot too. Oh, it's because we have an event for set explode and set normal explode, and we're gonna ignore this because the reality of this is these two data watchers I think are never actually properly used. There are apparently a few spots that actually do implement certain things. Let's see what we removed that we shouldn't remove. Oh yeah, so this one actually does do some update motion as well. This code really probably should be moved somewhere else, but we'll work with it. So this will be missile path delta and then X. Let's do missile path delta Z. More than likely what I'll come back through here and do later is I'll turn this into a getter method, that way there's no chance of this being null and crashing the game. And oh wow, we have a few different spots here. So this is the homing missile, which works a little differently than everything else. So we got missile anti and missile homing, so these actually have their own little data sets going on. Missile path delta dot X. This is an example where sometimes changing something to be something different does not actually work better for all cases. There's a way to take away from me changing that. The reason I'm going to use a vector for that is just it's going to be much easier to toy with. And more Chinese. There's a very likely possibility I'm going to have to come back through here and maybe rework the homing missile to make sure it actually does function still. And then this can be changed into equals new pause, and we just have to comma separate this. And what I'll do is I'll transfer this code over into the 112 version at some point in time as well. And I cut off, there we go. And that should work. Oh yeah, we forgot to do this. Missile path delta. There we go. And that sets the new delta position for that. The reality of looking at this is this code I don't think actually really needs to be stored where it's being stored. Because this is really just being used down here, so I don't think it's actually been used there. No, I guess this does seem to be used. So what this is doing is every single tick it's updating the missile path to aim at the target destination, and then it's letting the missile run its normal code to achieve its location. I'm going to assume the anti-missile does something very similar by the look of it. We'll definitely have to come back through here and document all this, and this will be a project for another day, and we may make a visualization piece of software just for it too, which I doubt it though. I don't see a real need for it, but it could be useful. And I'm going to change this to predicted position. Cool. Let's go back up to the top here where we were working. And go back to actually changing this. So let's go ahead and rename this right now. So this will be missile path max y is what this is going to be. So that way we get an easy to understand value. And all these are going to be prefixed with missile paths. We know these are all related. Eventually, what I might also do here at some point is come back in here and take all of this math and put it in its own object that's separated from the missile. That way we can recycle this code over and over and over again. So we go ahead and do this. I'm going to remove this because we actually have figured all this out now. Calculates the power required to reach the target coordinate. It's basically what this actually all does. So we go missile fly distance. We figure out what our distance is going to be to the target. Then here's some of our first variables here. So we got some settings here which we want to extract away. I'm going to just go ahead and put these up here. This is where you wouldn't actually put them in this exact spot, but we want to go ahead and get them separated out. So this is going to be call this missile path height init. So it's going to be very similar to the calculator variable is what we used, and we'll go ahead and set this. It doesn't really matter what this actually set to because we finally got the math set up in such a way that it won't break on us. So we got that, and then we're going to have our scale, so I'm going to just go ahead and duplicate this, and we'll put this at the top of the class where this will actually go. So we have our scale, which is 3. These will, for the 112 version, for the 1.7 version, I'm going to leave these in the missile class. For the 112 version, these will actually be moved to their own class file because of the way we handle configs in the newer version. Right now 1.7 we don't actually do that. This no longer actually needs to be an integer, so we can get rid of this cast int. And let's go ahead and also get rid of this and let's move this down as well. And if I can spell double correctly today, try it for the 3rd time. There we go. So let's move this back down to the rest of it as well. So there's actually a whole bunch of data here. When you're, by the way, storing fields and stuff in a class, it's always a good idea to store similar data types next to each other. So double, 4. By the way, I'm going to go ahead and change these to double as well so we don't have precision errors. That's going to double the memory usage of those two fields, but in reality, because the memory usage is so small, it doesn't matter. So this would be desired max Y value for missile path is what this will be. So this will not be the actual Y value, and that's the reason why I'm going to use the word desired, is because that's where we want to hit to, but what we're going to end up having at the top of the class is eventually two configs to control the max Y value. So let's go ahead and copy these and go put these at the top. And we want to put these up here. So there's already a speed variable. This speed, by the way, only controls the speed of a few other things. Let's update the Java docs up here as well. Let's see if I can find a Java doc here. I'm going to make sure I leave CalClavia's name here. If somebody else made the class file, even if you completely rewrote it at some point, you want to make sure that you actually put the author name still in there. So we're going to have to put CalClavia's name in there. We don't know when the creation date of this was, so we're going to be say created by CalClavia and reworked by me. And then we'll leave the date off of here for the moment. And we're going to go ahead and document it and say, okay, this is the entity for the missile object. And we'll probably come through here and add more documentation over time. So this will be speed limit of missile when not arcing. Because when the missile actually arcs, it's going to have a completely different speed limit than what this actually is. So this will be non-arcing speed. And we want to make sure we document our configs as well. So when somebody comes in here and goes like, what the hell is missile path height? This is an offset. And what you can also do in here is you can actually link to the variable this actually modifies to. So this modifies this. This is the offset for max height when calculated. I might actually make an event for this too, where it'll fire an event every time it goes to calculate the missile thing, and this would be a scale. Scale for max height when calculated, and that gets out everything. And we might as well document everything else while we're in here too. So this would be the explosive type contained in the missile. We actually switched over from using a flat ID system to an actual explosive index. I'm not going to actually rename the variables because of stuff. And we're not going to document everything, actually. That would be pretty much a bad idea. So target height is actually, well, I say that, and I probably actually should. But I'm going to do this later because I think the 112 version might actually be documented. If the 112 version is documented, I'm going to just copy the documents over later. And I am going to fix that because why is that misnamed? There we go. A lot of stuff is poorly documented here. This is an example right here where we have data that isn't needed, where I might want to come back through here and rewrite how the homing missile works, because if this is only used by the anti-ballistic missile or the homing missile, then really what should happen is the entity missile should have been extended and we should have spawned a completely dedicated missile just for the homing missile. And you're having a value down here that's not proper. Acceleration, explosive ID, target height, ticks and error. I don't know if we really need to be saving all this information, but what we're going to do is go ahead and set this to a double, and we're going to rename it as well. We're going to actually probably have to go through here and clean up everything. So I think this would be maybe a good opportunity to... and we actually recalculate everything right here, so you know what? I don't think we need to save some of this stuff. So if we're recalculating this as soon as it loads anyways, we don't really care about some of the data. We just need to make sure we have a target and a launch position. We need to make sure we have the explosive ID, we need to make sure it ticks an error, lock height, missile type, and additional missile data. So we need all this information. We don't need to save acceleration though, because it's not useful. And then... launcher position. Why is this name different? You know what, if your missile actually saved and loaded, it would have never worked. Because it's saving as one data type and it's completely different. Let's double check this. Lock height, everything's out of order too on top of this, actually. Target height. Let's see, target ticks in there. I mean, what it looks like stuff's there, so ticks in error, missile type, lock height, ticks error, explosive ID, just target height, explosive ID, switch positions for some reason. So it's all there, and what I end up having to do come through later is set these as static variable to clean it up. And as long as it recalculates the path correctly, this will be something that will definitely need to be tested in order to make sure it's actually working. Well, that's there, so that's cool. We don't need to mess with anything else on that regard. So back to this. Now we want to go ahead and stick our equation in here. So we have the equation, and if we scroll down all the way down here, and this is actually our proper equation. So this is what calculates the actual drag value. So we're going to copy this, and we want to replace this with this, and then we just have to rename some variables here. So max height is now missile max y. And then of course we've got missile path time is now flight time, or flight time is now path time. And then flat distance is this one right here. And I don't think we need to be globally storing some of these data points as well. I'm going to leave them in there though, because if we ever want to make a debugger that attaches to a missile so we can track it, especially if we want to make like some kind of display later on that you would build into your base to track to see what your missile is doing, it may be very useful to see this information in correlation to what you're doing. So that same exact visualization display we made outside a game, we may put that in game as well. And of course you would want this information for this to work. So that would be kind of useful. So that puts the equation in there. Let me double check to make sure that there isn't anything else I'm missing here. Missile flight right here needs to be changed. We want to make sure that still minus this ticks error, because that is actually pretty useful. And then did we change missile? Oh yeah, because we got rid of this. This is now a different value. This will be calculate drag. Let's go ahead and set this up. Yeah, that'll work. Well, it's not as clean as I would like it to be. We need to make this a static variable. We don't have a flight time minimum anymore, so this will go up here. And we're going to rename this. So this will be missile path ticks per meter is what this is. And this will be static, and this is also going to be a double now too. And we'll make sure we document this. Oh, actually no, that's not a double, it's an int, because the ticks are an init value. So this will be amount of distance traveled, amount of distance traveled, or amount of ticks traveled, or amount of ticks it required to travel a single meter flat distance when arcing. There we go. So that's documented out, and that would now be inserted into the function down here as well as something we can read. So we can actually read these variables. If you hover over these, by the way, here's how it's supposed to work. Wow, it's not working today. But normally what you do is you hover over this, it'll actually tell you what the variables actually mean if they have documentation on top of them. So we've got that set up, so the equation's in there. Our missile max height does look consistent. So, but we have min and max here, so we want to put our min and max variables in now. So put these up here. Public, static, final, double, missile, path, height, max. And we're going to set, we'll default this to 2000. We don't want to go higher than 2000 with the missile. And then public, static, final, double, missile, path, height, min, and we'll set this to 0. So I don't really care if your missile goes under a certain amount, because that's up to you guys if you want to change that. By default, I don't think a single missile will be below that number, so you shouldn't have to worry. Unless you set your missile distance to 1 and then your missile will explode right in the tube, that's impossible to do. So limiter for and link missile path y. And we'll just do that for both of them, because that's what that is, and it's understandable. And now we just got to implement both of those into the actual equation. And this will be pretty easy to implement into the equation, because literally what this ends up coming out to be. And we're going to actually leave this here just to make the code a little easier to read, as we'll make another line here. And we'll go equals math.max. And this will be where the min value is. The reason why we're saying maximum is we want to get the maximum of 2 values, and if the maximum of 2 values is your min versus your actual value, then it should limit it off. And then we're going to make this line again just to keep the code clean, and then we're going to have math.min. And once again, why you're doing a minimum is you want the smaller of the 2 values, and if you put your maximum value in here, then what should happen is if the max is underneath your current value, you're going to actually, I didn't set that to actually set that to the word max. No, it is max. What? Oh, because I misspelled this one. I forgot the T. But yeah, so when you have the minimum, it's going to pick the smaller of the two values. When you have the maximum, it's going to pick the larger of the two values. So if you have your minimum here and your max or missile Y somehow got below your minimum, it would then use the minimum. And for the math.min, it's going to pick the smaller of the two. So if your max value or your actual value right here goes above your max, then it's going to use the max value instead. So that works really, really well. So this would be limit by min and limit by max, just to make that 100% clear so nobody gets confused. And that should be everything. I don't see anything else we really need to clean up on. So we've got our delta calculated, which we're calculating delta up here. We're then calculating our flat distance, which we do right here. We're then figuring out what our max height is, which we do right here. Then we're figuring out our flight time, which we do right here, which is just ticks per n times flat distance. The reason why you don't see this in there is because this is used purely for the recalculation. So if you ever recalculate the path mid-flight some reason, you want to max off the ticks in time. That way your missile has a very consistent flight time. So if it took you 5 ticks to get out of the tube and it was supposed to take 200 ticks, it still takes 200 ticks to actually fly there. And what it'll do is this will modulate the actual calculation down here to ensure that it actually still works. What we're probably going to do is here later is modify this to actually do other things. For example, we might make it so the higher tier missiles fly slower, or we may make them fly faster, and of course this will be configurable in the future. And how this will work is we'll just modify the flight path time, because the flight path time, as you can tell, directly affects this equation. It has 3 spots that ends up in the equation, so this method should scale with anything we do. That's the reason why we ended up actually with these 3 variables in here, is that this drag value will scale with any change we actually make. So now this is all in here, what we can do is go in game and actually make sure that we end up with a consistent flight and that nothing goes wrong. So let's go ahead and launch the game, which is going to take a few seconds. Probably should have went ahead and launched in debug mode before we even started. That way we actually get anything. Now I'm not going to actually show how to do the configs. I'll do this in another video because the configs are pretty easy to do. They're consistent per version. So with the way we do it in 1.7 is we literally load up the config file and then ask it for values. In newer versions, there's an annotation system for this, which I'll show how to do that at another time as well. I believe Henneman, our guy who works on military base decor, has actually made a video for that for the Snow Power mod, showing how to make configs, so you can reference that as well. I'll do a little bit more in-depth one, because the way we do it for the 1.12 version of ICBM is we actually do have a category-based system. And did that actually crash? Let me pull up the debugger. Did not crash, we were still waiting for it to load. A little confusing on if Minecraft is running or not sometimes. So we are loading in the 1.7 version. My 1.7 workspace actually doesn't load slower, so more likely for this video I should have went with the 1.12, because the 1.12 workspace loads a lot quicker. I guess while we wait for this really quick, what I'm going to do is open my other workspace and I'll talk about the other version real quick. I will workspace, do new window. With IntelliJ, by the way, you can open as many workspaces as you want. It's still the same application though. So what I was talking about with the config annotation system is we actually ended up with an annotation-based system for configs. This is the reason why it will take a while to implement configs for the 1.12 version, and it's a lot different process. Normally, if I was going to implement this with the 1.7 version, I would use like a for loop to generate these. It would be a lot faster. But the cool thing about doing it this way is that somebody can open up the file and they know exactly what configs you have. They can clearly see them and access them. And it is a bit easier to work with because you don't have to have a lot of the overhead required of checking your data and setting things. A lot of it's done for you. You can set your data ranges and everything, so you can actually set your range here, and the code is a lot cleaner and easier to understand. As well, your category is pretty much set by just simply giving it a name with a slash behind it. So this is our blast category, we then have a launcher category, and then of course we have our main category. When we end up implementing the missile code, what we'll end up doing is just making another config here called like config missile, and that would actually modify all the configs related to the missile flight path time. It's pretty straightforward. Let's see how much more load time we have on the 1.7 version. So this is going to take a while to load. I'm wondering if it might be advisable for me to sit here and actually work on the configs while we wait for it to load. Shouldn't take too long to load. Normally, if I was actually going to video edit, what I'd end up doing is actually cutting right here and coming back, but I don't plan to edit this video. So I guess what we'll do real quickly is I'll show how this would end up working. So what we'll end up doing is I'll copy something like the blast, hit Control Paste. This would be config missile. we'll change this to missile, and of course there's a few things you want to change as well. For one, since we copied this, we want to change the date. Today's the 28th, not the 22nd. You could put a document up here saying this is configs for, and then do @link entity missile, and then of course we would want to get rid of everything we aren't using, and we would make sure we want to set things. So say for example we're doing speed, so we'll go speed, and we would set a simple variable called speed, and we document saying speed limiter of the missile when not moving an arc path, and then we got that. Yeah, so that'll work. I don't know why it actually just did that with IntelliJ, but likes to put brackets around things for some reason when you put a comma in there. I think it's a defect. And then we'd set the speed limit to some kind of value, and then we can actually pull that out of the entity missile right now, because that's actually set right there, and that's a float. That's what that actually is set to. And we of course come back over to the actual missile config. Let me close a few of these other ones, and we would actually put this right here, and that would be our config, and it would actually work. And we can put a range on the float here. Actually, there's no range float there, so range double then. Yeah, I guess that would be how we have to do it. So of course we want to make sure that you aren't going to be able to go below a certain value. So we say that's the smallest value you can have, and then we'll say let's please not go faster than 10, because then your missile will lightning before it hits anything. So by default it's set to that, and that'll work though. But somebody actually changed that config inside the thing, and then all we have to do is come up here and remove that speed check. And that speed check is actually made only in exactly one spot. And how that works is when we actually launch it, is that will, it seems to actually control the speed of leaving the missile tube. So we'll set this to config missile speed, and I'll more than likely have to implement this in another spot, because if this means that when we go to update the motion, that we actually are not doing this in any other type but just a flat missile spawn type, and we currently have a cruise launcher type and a launcher type, so these two have a speed value somewhere else, so this actually is not what that actually value means. So what we'll do is go ahead and rename this, and we'll rename launch speed, and we'll change this to be speed limiter of the missile when moving upwards out of the launcher. And we'll set another speed, because the cool thing about doing configs like this as well is we can set a speed for the RPG and we set a speed for the cruise launcher. Anyways, Minecraft 1.7 is actually loaded, so we can go check out our values now. And I can close this workspace, but that's how the configs would actually work for the 1.12 version. The 1.7 version, you would actually make a method called load config, and in there you would actually go through and manually load each of your configs. There is something similar to the annotation system for configs in 1.7, although not what I mean by actually there is an annotation for it, but there is actually that GUI. So the GUI you can get in the 1.12, where you can open and edit the configs inside the game itself. That does exist in 1.7, but it's not something we have. So there's actually here, and you can see test 1, test 2 disabled. That system was being developed in 1.7, but was never actually implemented, so needless to say that's not something we could actually really use. So for the 1.7 version, the configs will be different. Anyways, let's go ahead and build a launcher somewhere around here. We actually are going to have to put a power cube down for it and everything too, so let's go ahead and just build it on top of this tree. So we'll do that, and then I'll grab this so that way I have a platform to build on. And we'll place down our screen here. Get some glowstone out to set the battery to max power. Go ahead, and we don't want this version of ICBM. Likely though, I'll put the math we're working on in the other version of ICBM at some point. I don't know when, as I have been focusing a lot more on the classic version than I have been on the rewrite. So we'll get this out, and we'll get this out, and we'll go ahead and place these. And then we need to also get ourselves a place to put a lever so we can launch it. And we want to make sure we have a missile to launch. So we're going to launch a conventional missile because it's just easier to work with. And we have set the max height to 2,000, so I'm trying to think what exactly we run. So let's go ahead and pull out that visualizer we made, and this is another really good use for this, is that I want to know what distance I need to stick in this to actually get a Y value of 2,000. So this is the current data we're working with, and our max height is set to 2,000. So what value do I have to stick in to actually break that max height limit? So 1,000 won't get us there. 600 is really close, so it looks like 700. So we need to go at least 700 meters away from our current position in order to get there. So that's a really good use of this visualizer. So we actually know we need to be at least 700 meters. So what I'm going to do is set this to 700 meters away. And we're going to do it in the y-axis. So what actually I'm going to do is just set this to 1,000. So that way we're good. Our lock height I'm going to leave alone. Detonation I'm going to leave alone. And frequency I'm going to leave alone. So we have it in there. And you know what? I'm going to remote detonate this one just because I want to like set this up to be easy to use. Because if I try to pull that lever while I'm on the missile, it's not going to work. So let me get in the missile quick, and let's go and fire it. Now what we should actually see is, if we pay attention to this, and the animation is going to be glitchy, is really glitchy because I haven't gone through and actually fixed the movement animation, but we can watch our Y level, and what we should do is we should cap out at 2,000, and we can sit here and watch ourselves arc. That's the reason why I said the reason we built the visualization software is really hard to actually sit here and look at this and figure out, did we actually get it working right? Is the math actually modifying? What's going on exactly with it? It looks like we're plateauing out. So yeah, we just plateaued somewhere near 2,000. We're not perfectly at 2,000. The reason why we didn't actually stop at 2,000 is because the max height does not actually block it at 2,000. What it actually does is it prevents the missile from going any higher than 2,000 from its current position. So in reality, what the max height ends up being is the position you're at plus 2,000. So if you're at the top of the map at like 255, then you would end up stopping at 2,255. But we're arcing back down, and we're actually going to end up getting at some point. Still really do need to work on the missile flight code, because you can see I'm like pretty much hovering above this, and this has a lot to do with the fact that the collision box for the missile is right there. I'm basically sitting on top of the collision box, so the render of the missile does need a lot more work in the 1.7 and 1.12 version. I think the render is even worse in the 1.12 version than it is in the 1.7. So we'll definitely have to work on that. And we're almost back to the ground. By the way, missiles are a great way to travel. If you use the missile modular, it actually works great as a taxi. But yeah, so the math works. So it actually does do exactly what we thought it was going to do. So all the work and calculations to work on this visualizer over here have paid off. We have an equation that we can easily control. We can control the scale, we can control the init height, we can control the max and min height. Later I'll end up giving some configs to control the speed of the missile, so you can actually control how much time you want to take to travel across the X direction. And we'll probably not actually have any speed controls for the Y direction, simply because that will require a completely different equation to be used. But eventually, from what I understand, there's another developer who might help me actually build an equation where the speed is entirely based off the Y instead of actually being based off the X. But right now I do love the X direction. That's the one calc you put in there, and it makes 100% sense from a gameplay perspective, as you want to give the player an easy to understand metric on how you get from point A to point B and how much time it takes. Because if we end up giving them a really complicated equation that says, okay, you want to travel 100 meters, well, for 100 meters you're actually going to end up traveling a approximation of about 5,500 meters on the arc length, and if your missile only travels 2 meters a second, then that means you're going to take somewhere around 1,000 ticks to get there. Actually, it's probably closer to 2,000 ticks to get there, which then means you're going to be waiting an hour just to go 100 meters, and that would make the missile, from a gameplay point of view, not exactly the most useful thing in the world. Although I would like to point out, with this equation, if you went to go travel 100 kilometers, it would take you 3 hours, somewhere approximately that one. Actually, we can actually test this again. 100 kilometers. Given what the max value, it's not going to be dead on, so we can actually calculate this. And it will spit through that data here. You would have an approximate arc length of about 300,000. Which means it would take you, well, actually, that's right, arc length has nothing to do with the actual flight time. So you'd have a flight time of 200,000 ticks with this. So 200,000 ticks divided by 20 ticks per second, which is 10,000 seconds. You would take 166 minutes, which then divided by 60 get to, you're basically 2.7 hours to get there. That's 2.7 hours in real life. That's not in-game or anything else. So if you guys ever try to set the distance too high, you're going to have fun with that. We actually are going to implement chunk loading at some point to allow that to actually work, but I'll see you guys later with more videos on this content and more talks about how we're going to improve the mathematics and gameplay of both versions of the 1.7 and 1.12 version of ICBM Classic.